video for Dia's question. She sent me a question, I think it's from Education Perfect, that she's asked me to go through with you. Just like Mary's question, it's another one there. It's worth looking through. It is, again, an excellence question. So let's have a look at it. So the first thing we get told is that we have a width of the canal at ground level. So let's put in our width. So I'm just going to increase the size of our drawing and let's have a look. So if I put across there my x-axis, and that's my width, and then I'm told that it's 20 meters from there to there, so from 0 to 20, and if I make that my x-axis, I've gone nothing up, 0 to 20, which makes this my y-axis. Okay, now looking at it for the next lot. The sides of the canal can be modelled on a quadratic expression. Well, it's a parabola, so that's good. That gives us a maximum depth. So let's have a look. So we've got a maximum depth of 25. That means down here is 25 down. So we're going to have a negative 25 down here. And remember that our parabolas are symmetrical. So halfway between 0 and 20 is 10. So I can feed all of those points into my graphics calculator, as you know, and get the equation of my quadratic. So we're just going to do that. So go into the graphics calculator. We're going to go into statistics. And in our statistics, sorry, I've just got some equations here, so I'm just going to delete everything that I've got here. Go across and delete all. Okay, I'm going to put in my coordinates. So I've got 0, enter, go across 0. So that's my first coordinate. My next coordinate, remember, was 20, 0. And my last coordinate was 10, minus 25. So I've entered all of those coordinates. And I go across and I want to calculate. So I click calculate, F2. And I want to go backwards, so I'm regressing. And it's a quadratic, so it's x squared. So here you can see that we've got the equation, excuse me very much, A is a quarter, and B is negative 5. I have to say, sorry, Dia, when I first did this, I forgot to put in a negative 25. So I'm just making that correction now. So Y is a quarter for my A, and that's x squared. Then minus 5x for my B. If I look back at my C, you can see that it was a 0. So I've got the plus nothing. Then let's have a look at what the rest of it says. How the base of the canal is flat. So here's the base of my canal here. This is flat, and we're told that that is 8 meters long. Now, that means that the distance between the two endpoints here and here is 8 meters, and I don't know what they are, so I'm just going to say A and B. So B minus A, that length there is 8 meters long. Well, because at those particular points, A and B, we have this equal height or depth at this stage, which I don't know, but I do know that they're equal. So let's rearrange this equation so that I have either A or B. Let's leave it as B. So B equals 8 plus A. That means on one side of the equation, I've got 1/4 times B squared minus 5 times B, and it equals the same as the other one where I've got 1/4 A squared minus 5 times A. Now I'm going to substitute in what we've worked out for B. So therefore we've got 1/4 times, let's just turn it around to A plus 8 squared, so I'm just going to write it out twice, minus 5 times A plus 8, and that all equals 1/4, I don't need to actually put the brackets there, A squared minus 5A. Let's expand this quadratic, giving me a quarter. A times a is a squared. A times 8 is 8a plus another 8a gives me 16a plus 8 times 8 is 64. Minus 5 times a is 5a. Minus 5 times 8 is minus 40. Equals, again, my quarter, a squared minus 5a. Let's expand out this quarter, giving me 1 quarter a squared plus a quarter of 16 is 4a, and a quarter of 64 is 16. Yeah, 16. So plus 16 minus 5a minus 40 equals quarter a squared minus 5a. Start collecting these like terms. So we've got 1 quarter a squared. We've got 4a minus 5a is minus a. 16 positive minus 40 gives me minus, what is that? Minus 24 equals 1 quarter a squared minus 5a. Now I'm going to add 5a to both sides, giving me 1 quarter a squared plus 4a minus 24 equals a quarter a squared. And I'm going to subtract a quarter a squared from both sides, and they disappear, giving me 4a minus 24 equals 0. It gives me 4a equals 24. Divide both sides by 4, giving me a is 6. Now, if they asked me to find both of those, I could find b by substituting a into my formula, 8 plus a, giving me 8 plus 6 equals 14. But that's not what my question asked, but it's nice having both of those x values. So I know, what I know right now is that instead of a and b, that I can say that this was 6 and it was 14. Now, what I wanted to find out was the y at that particular stage. So it says, what is the actual depth? That's the y. So I'm going to re-put out my equation, which was y equals 1 quarter x squared minus 5x. And we're going to substitute our first one in there. It doesn't matter whether I do my first one or my second one. I'm just going to substitute in my first one. So 1 quarter times 6 squared minus 5 times 6 is 1 quarter times 36 minus 30. 1 quarter of 36 is 9 minus 30 is minus 21. Remember that this is an actual depth, so therefore the depth of the canal is 21 meters. And that's what that negative means there. The negative means that I'm down 21, so depth. Okay, hope this helps. Have a nice evening.